All right. So in this particular triangle, we have all the side lengths around, and the question is, what is the distance from this vertex to this random point over here that kind of splits up the triangle? We want to know that length, and we're also interested in this angle right here. Okay. So uh, if you wanted, you maybe try law of sines. Law of sines. Oh yeah, to use the law of sines, you have to know an angle. We don't have an angle. So this is going to be, we have side, side, side. We're probably going to be using law. Oh, hey, they give us the law of cosines formula right here. Let's just try it out. Uh, so let's look for, we're looking for this angle. Let's try to find that angle. It is across from the x, but I don't know the x. But it's also across from this big O 10. So for that overall triangle, all right, this overall triangle, I've got 8, 10, and 12. So since my angle is across from that 10, I'm going to let my 10 be my side that's across from my angle. All right, I'm going to plug in my 10 for this A right here. And the theta, that's going to be the part that I'm solving for there. All right, so let's get that done first. So we've got 10 squared. 10 squared is 100. That's equal to, so B and C, these are going to be my included sides, or sorry, my sides that are around my included angle. So that's going to be 64 for 8 squared plus 144 for C squared minus 2 times 8 times 12. So minus, 2 times 8 times 12, 2 times 96, 8 times 12 is 96, times the cosine of A. I can go ahead and put these together. Let's do, actually, I'm feeling a little bit different about it. Instead, eventually I know I'm going to move everything over to the left side, but what I'm going to do, I'm going to cancel out this 100, and I'm just going to take it away from that 100 right there. All right, 64 plus 44, that's equal to 108, but I need to minus that 108 and move it to the left side. So I get negative 108 for these two parts. That's equal to negative 2 times 96. That's 180, 192. 192 cosine A. I can get rid of these negatives. I don't need those negatives any longer. Okay. Divide by 192 here. Divide by 192. All right. I could simplify this, but it doesn't matter too much. I'm going to be doing the inverse cosine of this big O fraction. All right. So cosine inverse of 108 over 192, and that's going to solve for my missing angle here. Okay. So inverse cosine of 108 divided by 192. And that gives me 55.57. 55.77. And if you wanted to, you could actually store that to theta or store that to x on your calculator if it would help you. That way your answer would be more exact. Just take that one and stow. I just hit the stow button and then X. It might help you if you want to get your answer as close as you can. So now I've got this one. Well, now I can solve for X because I have side, angle, side. That way I'm going to be able to solve for the side that's across from theta. No, not the 10. I already had the 10, this X. So now I'm looking at the tiny triangle. All right. I can let x be my missing side, and the angle that's across from it is going to be my theta here. All right. So let's set up that equation now. Jeez. All right. So I'm going to say a squared or x squared. And 8 and 7, those are going to be my b and my c. Those are the two sides that are surrounding my included angle. So 8 squared is 64, 7 squared is 49, minus 2 times 8 times 7, 2 times 56 times cosine of A. Okay, I can combine those real quick. It's 113 minus 112. That's weird. I wonder if that always happens. These have always been different by 1, at least in these examples I've done. I wonder if that always happens. Times the cosine of A. Oh, cosine of, and I know A, don't I? Shucks. I probably should have put that up here too. Cosine of A, which was 55.77. 55.77. And then from here, yeah, I need to use a calculator. All right, so I'm going to do my right side, 113 minus 112 times the cosine, 55.77. And I get about 50. That's basically 50. All right, you could write it as 49.9 if you wanted to. I'm just going to say 50. It's really, really close. Then you would square root both sides. So the answer is going to be the square root of 50. Square root of our last answer is 7.07. And that will do it. That is that weird segment that goes from that vertex to the opposite side. 7.07. I guess from there, if we really, no, we won't take it any further. But boy, we could. Now that we've got, oh yeah, we could definitely go further.